Hey class, welcome back to another session of Stephanie's math stuff. Yeah, let's just call it that. So today, our lesson will be on polynomial functions. I don't know if you guys can see, but if you see faint markings on the graph, it's because my marker is terrible, and when I try to redo this problem, it left marks already. But anyway, we'll still do it. So based on the exponents, we can tell that our degree will be 5, because 2 plus 3 is 5. And using that, we can see our number of solutions will also be 5. And also using that, we can see the number of turning points will be at most 4. Because the number of turning points is always degree n minus 1. So 5 minus 1 is 4. Our leading coefficient is obviously 1. And we can tell, based on the leading coefficient, that our graph will rise right. I'm going to put rise R. And fall left. Now, just using a little bit of basic algebra, we will set the x to 0, which will make it negative 2 squared and 1 cubed, and 4 times 1 equals 4, which by that we can tell our y-intercept will be 0, 4. Now we can try to graph it. So excuse me, I'm going to be blocking the camera for a bit here. Let's see. Wow. Boom. Boom. Done. It looks terrible, I know, but we're not focused on the graph here, okay? So now we can tell our domain and range, which is x such that x equals all real numbers, and y such that y equals all real numbers. And based on the graph 2, we can also tell the zeros, which will be 2 and negative 1. And if you want some basic algebra to see how that will be done, you could just set x minus 2 equal to 0, which will get x equals 2. And you could just set x plus 1 equals to 0. Get you x equals negative 1. But also check for multiplicities, because that will tell you, when you're graphing, as you can see, whether the graph will bounce or if it will cross through. Whether a line will bounce or cross through, my mistake. And as you can see, where x equals 2, the bounce has an even multiplicity of 2, which caused it to bounce here. Multiplicity of 2, while my handwriting is bad. And where, as we can see, where x equals negative 1, it had an odd multiplicity of 3, which caused it to cross through. And now all we have to do, using our handy dandy calculator here, is find the increasing and decreasing values, and also the relative min and relative max. So I already did the work here and I plugged it in. And when I plugged it in, I saw that the increasing would be from negative infinity to 0.8. Now that I couldn't tell by just looking at the graph. I actually had to find the max to see what it will be increasing to. And also remember that it's increasing from here to here and from here to here, which will be from 2 to infinity. And the decreasing value will be from 0.8 to 2, which that part is fairly simple. Once again, I apologize for my bad handwriting. And then, last but not least, we just have to find the min and the max. And the relative min will be at x equals, you got it too. Even though you didn't say it, I know you were thinking it, so you got it. And the relative max will be at x equals 0.8. Which, if you don't trust my graph, which I wouldn't, you could just plug into your calculator and you could find the answer that way. So, that's all you do for polynomial functions. Based on my awesome teaching, which it really wasn't, you should get an A on this test. And when you do, shout out Stephanie at Stephanie's Math Lessons on Instagram. Follow me. Don't. Please don't. Okay. That's all for the video, guys. Bye. And see you next time.